Hello, welcome back. I'm John, an old YouTuber and PC gamer. So I did download all this more, I think that's 20 PDF about computer programming. So let's start to do this, but I need to put this memory card back in camcorder because I just made a small Danish video. It's already public. I was eating a little bit food, a little bit vegetables and olives, but I'm not going to talk 5 minutes now. I just like to continue. I need a shower, the shaving, so I should do that. But now I did read this sample language. All this video are on my playlists, so you have to watch it from my playlist if you can understand how I did record this, because you're supposed to read it in kind of orders. So that's my new read list about computer science, computer programming, programming language, high-low level, high-level programming, compiler, binary code, machine code, little man computer, that's a educational computer from the 60s, the C programming language, C++. I don't think you can write C++ on YouTube this later, so I have to write C++. Basic, Visual Basic, Fortran, Algol, COBOL, Pascal, Turbo Pascal, and Lisp. So probably there's a lot more programming language, but this will take many weeks and weeks and weeks and weeks, and this is what I like. I like to read about this Intel CPUs. I have it down there, all this list of Intel CPUs. I'm going to make a new list there. I like to go there. But now I have to spend 1 week, probably it will take 1 week to do this. I don't know, long time. Now it's Monday. It's 1:30, so let's get started. I have already have this PDF open. Computer science. Yes, I have to adjust the screen a little bit. So, but that's really helped me a lot. When I'm reading, I have this computer voice reading same time. I'm reading this same time. I'm not just sitting and looking. This is how my mouse is moving. Oh, I think that's not level. When this computer voice is reading, I'm moving my mouse. That's because I'm reading. Same time I'm reading this. Computer science is the study of computation, automation and information. Computer science spans theoretical disciplines such as algorithm, theory of computing, information theory, to practical disciplines including the design and the implementation of hardware and software. Computer science is generally considered an area of academic research and distinct from computer programming. Yes, I don't think you would like to listen to my voice read this in many hundreds of hours, because my voice is not very good anymore, because I'm starting to get older. I'm older male, age 56, soon age 60. So my voice had changed too, and I not speak so well English. So this worked very well. But now these letters are a little bit small. I have a little bit problem to read it. Yes, let's just start. Read the whole document.
Computer science. Fundamental areas of computer science: expression for Church numerals in lambda calculus. Programming language theory: plot of a quicksort algorithm. Computational complexity theory: example of computer animation produced using motion capture. Artificial intelligence half-adder circuit. Computer architecture. Computer science is the study of computation, automation, and information. 1. Computer science spans theoretical disciplines, such as algorithms, theory of computation, and information theory, to practical disciplines, including the design and implementation of hardware and software. 2. 3. Computer science is generally considered an area of academic research and distinct from computer programming. 4. Algorithms and data structures are central to computer science. 5. The theory of computation concerns abstract models of computation and general classes of problems that can be solved using them. The fields of cryptography and computer security involve studying the means for secure communication and for preventing security vulnerabilities. Computer graphics and computational geometry address the generation of images. Programming language theory considers approaches to the description of computational processes, and database theory concerns the management of repositories of data. Human-computer interaction investigates the interfaces through which humans and computers interact, and software engineering focuses on the design and principles behind developing software. Areas such as operating systems, networks and embedded systems investigate the principles and design behind complex systems. Computer architecture describes the construction of computer components and computer-operated equipment. Artificial intelligence and machine learning aim to synthesize goal-oriented processes such as problem-solving, decision-making, environmental adaptation, planning and learning found in humans and animals. Within artificial intelligence, computer vision aims to understand and process image and video data, while natural language processing aims to understand and process textual and linguistic data. The fundamental concern of computer science is determining what can and cannot be automated. 6, 7, 8, 9, 10. The Turing Award is generally recognized as the highest distinction in computer science. 11, 12. Contents. History. Etymology. Philosophy. Epistemology of computer science. Paradigms of computer science. Fields. Theoretical computer science. Theory of computation. Information and coding theory. Data structures and algorithms. Programming language theory and formal methods. Computer systems and computational processes. Artificial intelligence. Computer architecture and organization. Concurrent, parallel and distributed computing. Computer networks. Computer security and cryptography. Databases and data mining. Computer graphics and visualization. Image and sound processing. Applied computer science. Computational science, finance and engineering. Social computing and human-computer interaction. Software engineering. Discoveries. Programming paradigms. Academia. Education. See also. Notes. References. Further reading overview. Selected literature. Articles. Curriculum and classification. External links. Bibliography and academic search engines. Professional organizations. MISC. History. Charles Babbage, sometimes referred to as father of computing. 13. Ada Lovelace published first algorithm intended for processing on a computer. 14. The earliest foundations of what would become computer science predate the invention of the modern digital computer. Machines for calculating fixed numerical tasks such as the abacus have existed since antiquity, aiding in computations such as multiplication and division. Algorithms for performing computations have existed since antiquity, even before the development of sophisticated computing equipment. Wilhelm Schickard designed and constructed the first working mechanical calculator in 1623. 15. In 1673, Gottfried Leibniz demonstrated a digital mechanical calculator, called the stepped reckoner. 16. Leibniz may be considered the first computer scientist and information theorist, for, among other reasons, documenting the binary number system. In 1820, Thomas de Colmar launched the mechanical calculator industry. Note 1. When he invented his simplified arithmometer, the first calculating machine strong enough and reliable enough to be used daily in an office environment. Charles Babbage started the design of the first automatic mechanical calculator, his difference engine, in 1822, which eventually gave him the idea of the first programmable mechanical calculator, his analytical engine. 17. He started developing this machine in 1834, and in less than 2 years, he had sketched out many of the salient features of the modern computer. 18. A crucial step was the adoption of a punched card system derived from the Jacquard loom. 18. Making it infinitely programmable. Note 2. In 1843, during the translation of a French article in the Analytical Engine, Ada Lovelace wrote, in one of the many notes she included, an algorithm to compute the Bernoulli numbers, which is considered to be the first published algorithm ever specifically tailored for implementation on a computer. 19. Around 1885, Hermann Hollerith invented the tabulator, which used punched cards to process statistical information. Eventually his company became part of IBM. Following Babbage, although unaware of his earlier work, Percy Ludgate in 1909 published 20. The 2ND of the only two designs for mechanical analytical engines in history. In 1937, 100 years after Babbage's impossible dream, Howard Aiken convinced IBM, which was making all kinds of punched card equipment and was also in the calculator business. 21. To develop his giant programmable calculator, the ASCC/Harvard Mark I, based on Babbage's analytical engine, which itself used cards and a central computing unit. When the machine was finished, some hailed it as Babbage's dream come true. 22. During the 1940s, with the development of new and more powerful computing machines such as the Atanasoff Berry computer and ENIAC, the term computer came to refer to the machines rather than their human predecessors. 23. As it became clear that computers could be used for more than just mathematical calculations, the field of computer science broadened to study computation in general. In 1945, IBM founded the Watson Scientific Computing Laboratory at Columbia University in New York City. The renovated Fraternity House on Manhattan's West Side was IBM's first laboratory devoted to pure science. The lab is the forerunner of IBM's research division, which today operates research facilities around the world. 24. Ultimately, the closer relationship between IBM and the university was instrumental in the emergence of a new scientific discipline, with Columbus offering one of the first academic credit courses in computer science in 1946. 25. Computer science began to be established as a distinct academic discipline in the 1950s and early 1960s. 26. 27. The world's first computer science degree program, the Cambridge Diploma in Computer Science, began at the University of Cambridge Computer Laboratory in 1953. The first computer science department in the United States was formed at Purdue University in 1962. 28. Since practical computers became available, many applications of computing have become distinct areas of study in their own rights. Etymology. Although first proposed in 1956, 29, the term computer science appears in a 1959 article in Communications of the ACM, 30, in which Louis Fain argues for the creation of a graduate school in computer science is analogous to the creation of Harvard Business School in 1921. 31, justifying the name by arguing that, like management science, the subject is applied and interdisciplinary in nature, while having the characteristics typical of an academic discipline. 30. His efforts, and those of others such as numerical analyst George Forsyth, were rewarded. Universities went on to create such departments, starting with Purdue in 1962. 32. Despite its name, a significant amount of computer science does not involve the study of computers themselves. Because of this, several alternative names have been proposed. 33. Certain departments of major universities prefer the term computing science, to emphasize precisely that difference. Danish scientist Peter Noe suggested the term datalogy, 34, to reflect the fact that the scientific discipline revolves around data and data treatment, while not necessarily involving computers. The first scientific institution to use the term was the Department of Datalogy at the University of Copenhagen, founded in 1969, with Peter Noe being the first professor in datalogy. The term is used mainly in the Scandinavian countries. An alternative term, also proposed by Noe, is data science. This is now used for a multidisciplinary field of data analysis, including statistics and databases. In the early days of computing, a number of terms for the practitioners of the field of computing were suggested in the Communications of the ACM: Turing inertiologist, flowchartsman, applied metamathematician, and applied epistemologist. 35. 3 months later in the same journal, Contologist was suggested, followed next year by hypologist. 36. The term computix has also been suggested. 37. In Europe, terms derived from contracted translations of the expression automatic information, for example informazione automatica in Italian, or information and mathematics are often used. For example informatique, French, informatique, German, informatica, Italian, Dutch, informatica, Spanish, Portuguese, informatica, Slavic languages and Hungarian, or plierophoriki, which means informatics, in Greek. Similar words have also been adopted in the UK, as in the School of Informatics, University of Edinburgh. 38. In the U.S. however, informatics is linked with applied computing, or computing in the context of another domain. 39. A folkloric quotation, often attributed to but almost certainly not first formulated by Edsger Dijkstra, states that computer science is no more about computers than astronomy is about telescopes. Note 3. The design and deployment of computers and computer systems is generally...
Yes, I have to pause a bit because I have to look my cell phone. I did that last time. I need 2 minutes to reply something. I'd like to read this. So sorry for that small break.